class, today we're looking at Chapter 8, Lesson 6, Transformations and Similarities. So smartphones and tablets have a zoom feature. That makes a figure larger or smaller. A swipe feature lets you slide the figure around on the screen. When you use these two features together, the final figure is smaller to the original figure. If two figures are similar but not congruent, then a dilation or a dilation and a sequence of transformations will map one figure onto the other. So determining similarities using transformation. You use the zoom and swipe features on your smartphone to enlarge and then move an image of a bee on the screen. Describe the sequence of transformations that map the original image of the bee onto the image that is similar. So checking these out, right? This first one here is the original, and then it's zoomed in, and then it's centered. So this we will say a dilation with a scale factor of 3.5 maps the original image of the bee onto the first zoomed image. A translation to the map to the left maps the zoomed in image on the final image to the original image. So all of that. So really today, your assignment is you're describing what happened. So using a computer graphic designer moves a company logo from the top left to the bottom center of a page and then enlarges the logo as shown right here. Describe the sequence of transformation that maps the original logo onto the final. So what happened first? First, a translation, right? A translation means it's moved down. A translation, it's moved. So we're going to put that it was moved down. A translation down, then right, followed by a dilation. That means it's getting bigger. Sorry, my spelling there was a little off. With a scale. So now how much bigger is this second one than this first one? 1 times what equals 3? 1 times 3. So a scale factor of 3 gets bigger by 3. And that is your answer. Please write that down. Okay, so there is more than one way to do this. So let's check out this figure. So determined whether triangle ABC is similar to ZYX. So Tina says, I can use a sequence of transformations to prove triangle ABC is similar to triangle ZYX. So she says, rotate triangle ABC 90 degrees about the origin to get triangle ABC. So here's where it starts. It gets rotated to 90 degrees. And then she says reflect ABC over the x-axis to get A, B, C. So that turns into this one. and then dilate ABC by the scale factor of 2 with the center C to get ZYX. I can map triangle ABC onto ZYX using transformation with a dilation so the triangles are similar. So that is Tina's method. Roberto says I can use SAS similarity theorem to prove that the two triangles are similar. So he says angle B is equal to angle Y because they are both right triangles. AB and BC equals 3 over 2, and ZY and YX equals 6 over 4, which is reduced to 3 over 2. So therefore, triangle ABC is similar to triangle ZYX by the SAS similarity theorem. Remember, that was side, angle, side. So really, either one is correct. So we do have a challenge here. I don't know if I left quite enough room on our page. I don't think I quite realized this was a problem. We'll do that below. Okay, so translation is whenever a figure is being moved in a direction on a graph. So a translation, moving on a graph without rotating or resizing. And then a reflection is a transformation with a flip of a figure. So right, if it was a reflection over the y-axis here, a reflection. A translation, sorry, let's go back and do. And it could be anywhere. So this could move over here. Okay, translation, reflection. So a rotation is where it rotates around a certain point. Okay, and let's do an example of that. So if we have this here and it's rotated 90 degrees clockwise, then it's going to be like that. It goes all the way around. This is where it would be if it was 180 degrees. And this was where it would be if it was 270. And that's only if this is the original. Okay, so that's a rotation. And then what we discussed today, a dilation. And so, right, a dilation is either a enlargement, oops, wrong thing here, enlargement or reduction in an original figure. Okay, so those are the 4 things that you're going to be using to describe these transitions, transformations, and then proving similarity. Remember, you can use either Tina or Roberto's method. So oops, missed a D there. Your homework today is page 284, number 3 through 13 odd. Happy homeworking.